Hey everyone, my name is Rohan Alexander, assistant professor at the University of Toronto, and joining us this week is Tom Davidson, who is an assistant professor at Rutgers. Thanks very much. So Tom, do you want to tell us a little bit about your background? You're not from the US. How does a nice boy from England end up in the US?
Yeah, so thank you for inviting me here today, Rohan. Um, I had my training as an undergraduate in the humanities, and I continued to do my studies, and I did a master's degree in political sociology. And during my master's degree, one of the things I became interested in is how social movements were increasingly using social media to gain support, and in particular, how extreme right movements were suddenly getting tons and tons of support online, far more support than any established political parties. And so this was happening in the UK back in 2012, 2013. And now we see like these same types of actors are, well, until recently were in the White House. Um, and so as I was studying these groups, I initially started out doing a traditional qualitative content analysis of the discourse of people who are writing comments on these far right Facebook pages. And I remember spending about 3 months over the summer in the LSE library in London, just reading through all of these Facebook comments and coding them all up in NDivo. And I think I got through about 1,500. And I had this very, very complex coding scheme. And I was certainly able to learn a lot through that qualitative analysis, but I really ran up against the limitations of these types of methods in terms of dealing with this type of discourse at scale and dealing with the fact that this language was really changing and transforming a lot over time. And so when I started my PhD, which I ended up coming to the US and doing my PhD at Cornell, largely because funding for graduate studies is much better over here than it is in the UK, where many students are unfunded. And also the PhDs in the UK tend to be much shorter. When I got to Cornell, I realized that I needed to start learning how I could do some of this work in a more automated fashion and deal with much larger corpora of data. And that led me to start taking undergraduate classes in computer science, which then led me on to taking graduate classes in computer science and TAing for some grad computer science, NLP classes. And so I kind of became absorbed into this world of doing like computer science research at the same time as I was doing my graduate degree in sociology.
That's incredible. So just briefly on the grad school side of things, because I know a lot of people have questions about PhD applications and things like that. So you were very much you had this idea in mind. You wanted to explore this idea, and it ended up that you were sort of 10 years ahead of your time, ahead of the time, and it ended up working out in your case. But your challenge was really in terms of developing those quantitative and statistical and maybe computational sort of skills. And this coincided with the rise of computational social sciences.
Right.
And so are you very much more of a data first sort of academic, or do you have these research questions? Some
Yeah.
people are skills first. They try and attack everything with the same statistical methods. So.
That's a really good question. I think as sociologists, we like to think about theory guiding our research questions and our approaches, but often we are guided by what data we have available. And I think, a lot of computational social science, for example, uses Twitter because it's one of the most widely available large data sets. So I think in my research, it's often a back and forth between the data and the research questions. And often, if you collect a new data set, you might suddenly stumble across new research questions that you could answer using that data set. So I wouldn't say I have like a clear position on one side or another. I certainly have projects that have been driven by having interesting data sources to analyze, and other projects where I've had data sources and I've suddenly realized there are questions that we could answer using them.
And so one paper in particular uses Twitter data, and I think the whole Twitter archive is now available to academics. I think this may have only just happened in the past week or two, but this is a paper from a few years ago. and it's available on archive for free. Otherwise, it's been published in the third abusive language workshop. And this paper is looking at sort of racial bias in hate speech data sets. Did you want to talk a little bit through that
Yeah,
paper?
so why don't I have some slides prepared. So let me go and share my screen and we can kind of dive into some of this.
That looks good.
Great. Okay, so I thought I would just give a quick talk today that provides a bit more context to this paper. So the topic of this talk is the case of hate speech detection and how it relates to this kind of broader problem of bias in machine learning and classification systems. So there are kind of three parts. I wanted to provide a bit of background about the purpose of systems to detect hate speech online. I wanted to talk about this specific paper that you've had a chance to take a look at, and then just highlight very quickly a couple of challenges that hopefully some of the students in the room might be interested in taking up and working on. So hate speech detection itself, at face value, seems like something very easy. It seems like we should just know what hate speech is when we see it. But as it turns out, it's a very hard problem. And Mark Zuckerberg has famously said that it's easier to detect a nipple than detect hate speech with AI. And some of you might be able to think about reasons for this, right? There are many images of nipples online, and it's relatively unambiguous what a nipple is, or at least what a human nipple is, although there is still controversy around like which nipples are acceptable on which social media platforms. And so there's been a lot of interest in hate speech detection, particularly as social media has become more and more prevalent and people have become aware of some of the risks involved with social media use. And so this has been an area of research that really kind of exploded while I was in grad school, really over the last 5 or so years. And so this is from an index of citations in computer science conferences. I know for a fact that this is an undercount, but I think it represents the kind of general trajectory here. So there are various different ways that we could define hate speech. And this has been an issue in the literature that many papers use different approaches. I won't go into this in much detail today, but just note that there are various legal definitions. For example, in the US, much of this speech is protected by the First Amendment, whereas in countries like Germany, there are, you could go to jail for using certain types of prohibited speech online. Different social media platforms have policies about hate speech that have been constantly changing and evolving. As academics, we also have our own definitions. And then there are also these common sense definitions of what constitutes hate speech that kind of have a role to play in this research. So when I started out in this area, I never planned to actually work on machine learning systems for detecting hate speech. Our original research question was actually, we were interested in studying communities of people who used hate speech on Twitter from a more sociological perspective. And so it was something that my advisor was working on already. And I had been doing work, as I mentioned, about the far right on Facebook. And so it seemed like a good fit for me to join this project. And what we quickly realized was that the existing work on hate speech detection was quite limited. And so a lot of the work was dictionary based. And so we got our hands on this dictionary called HateBase, which is a crowdsourced lexicon of potentially hateful terms. And it's kind of marketed as being like the leading lexicon for detecting hateful language online. And so the problem with using a dictionary based approach is it's very high recall, but very low precision. So it's kind of like a trawler where you want to perhaps catch some tuna, but you're also catching lots of dolphins and sea turtles and all sorts of other things in your net. And so these dictionaries are able to pick up a lot of stuff, but they get lots of, for example, tweets, which are completely innocuous. And so one of our goals was to think about if we could improve precision. Is there a method we can use to go and grab the thing we want, go and get these tuna with a line, and to keep the dolphins and everything else in the sea? And so one of the things that we noticed based on the previous literature was that a lot of the existing work, even the work that did try to use machine learning, tended to conflate hate speech with other forms of offensive language. So things like cursing online that some people no doubt find offensive and it may be hurtful, but it's clearly a different type of language to, for example, hate speech used by white supremacists. And so we developed a data set by using crowdsourcing, where we asked people who were doing the crowdsourcing to distinguish between whether a given tweet was hateful, if it was offensive but not hateful, and we provided some examples to help them make their decisions, or whether it was neither of these. And this was based on tweets which all contained at least one keyword from that hate-based dictionary. So according to the dictionary-based approach, all of these would be considered hateful. And so what this plot here shows is a matrix of the true categories versus the predicted categories after we trained a machine learning model on this annotated data. And so what we can see is the model was actually quite good at detecting both this content that didn't have any hateful or offensive language and the content that was just offensive. And it made the most errors in this category of distinguishing between what was hateful or what was offensive. And one of the issues happening here was that the human coders were genuinely, they found it to be a genuinely hard problem, that in many cases they disagreed or couldn't really figure out if something was hateful or offensive. And when we dug into this a bit more, and in the paper, we do an analysis of picking out some examples that fall into various categories here, we found often that some of the false positives would be things like rap lyrics, where we would see this sentence that seemed very hateful and we would Google it and it was like a line from a rap song. And so we noticed already in this paper that we were seeing some potentially racialized false positives occurring. So the issue of racialized false positives is something we brought up and had been mentioned in some other papers on hate speech detection and related problems of, for example, there's a paper by Davidson and colleagues at Google looking at the Perspective API, which detects online toxicity. And so there were issues with false positives arising due to race and dialect and certain language being used by African Americans that was being picked up and flagged falsely as hate speech. There were issues with identity terms. So for example, Dixon's paper shows that if you have two sentences where you have exactly the same content, but you might say, for example, I am a straight man versus I am a gay man, that the one that says gay man would be flagged as more toxic because of the way that gay might be used in a pejorative way in some contexts. And then there's also the issue of counter speech and resharing. So perhaps you're a victim of hate speech and you reshare this with your friends and say, you know, look at this horrible thing someone said to me. And then the machine learning algorithm falsely classifies you as actually being a user of hate speech yourself. And this is a common reason why people are being blocked on Twitter all the time, for example, bringing up like people who write some parody about COVID misinformation and then get their Twitter account blocked. So we wanted to look at how systematic this phenomenon was. And so along with Deb Bhattacharya, who was an undergraduate at Cornell and is now a master's student in CS at Cornell, and Ingmar Weber, who was a collaborator of mine in our earlier paper on hate speech, we wanted to systematically evaluate various different available data sets that had been annotated for hate speech or various other categories of offensive language, and to see how these data sets classified language that was used in either standard American English or African American vernacular English. And so we came across a data set where some other researchers had already annotated a very large corpus of tweets for which ones were written in standard American English and which ones were written in African American vernacular English. And so what we did here is we collected 5 different data sets, including the one that I helped to create in 2017. And with each data set, we trained the classifier using cross-fault validation and got the best classifier. I think in this case, we just used logistic regression because it tends to do pretty well in these cases. You can do better by using something like deep learning, but our point wasn't to optimize for predictive accuracy. It was just to get a reasonable model. And then what we did was we used a bootstrap approach to apply this classifier to small samples drawn from these larger corpora of either African American English or standard American English. And in each case, we would classify all of these tweets and then calculate the proportion of those tweets that were being categorized as either, you know, in the case of our paper, hateful or offensive, in the case of other papers, racist or sexist, This one dataset, Founter et al., had either hateful, abusive, or spam. And what we see here is in almost every single case, a greater proportion of the African-American English tweets are flagged as being hateful or offensive or abusive than tweets written in standard American English. So almost all of these classifiers universally have some type of racial bias. And this effect remains even if we only look at tweets that contain, for example, the word bitch, where we know that, okay, that tweet has some baseline level of offensiveness. We still see that the tweets written in African-American English are being flagged at a higher rate as potentially abusive than the other tweets. And this even exists, for example, the Wasim and Hovey papers. They had their annotators were people who were trained in, they were people who are self-declared intersectional feminists, who we might think of as being less biased in the decisions they're making because they're very attuned to these types of things. And still the classifier trained on their annotations, which funnily enough, most of their tweets come from a Twitter controversy about an Australian TV show. So there's another kind of odd bias in their data set, but we still see this bias occurring in their, in the classifier trained on that corpus. And just a word on how quick the publication cycle is in computer science compared to sociology. At the same conference where we published our paper, there was another paper published that was also about racial bias and hate speech detection. And so we were very, very close to being scooped. This one was actually in the main proceedings, and I would encourage you all to check it out. It's a great paper. And they look at something very similar to us. They have this great graphic here that illustrates how an African-American English speaker using exactly the same semantic content as a standard American English speaker is having their content flagged as much more toxic by the Google Perspective API. And in this paper, they also do some interesting experiments, which I'll talk about in a second, to try to guess at kind of what's causing this. So we also conducted one follow-up paper where we had a short paper where we were interested in using structural topic modeling to see if we could use unsupervised learning to uncover these types of biases. And what we found is that there were two topics in particular that seemed to contain most of the offensive terms, which you can see at the top of this plot, topic 4 and topic 20. And one of these topics, the one that was associated with African-American English, tended to be flagged as much more abusive than the other topic, which was just more generic swear words. And so we do see in this topic modeling approach that we're able to potentially uncover tweets that might be both highly likely to be flagged as abusive in this case, and also contain high proportions of African-American vernacular English. So I'll quickly wrap up. What are the implications of this? So the biggest implication here is that these models lead to discrimination, that the models we're designing to potentially protect communities like African Americans, who are often victims of hate speech, may end up disproportionately classifying African Americans as the actual users of hate speech. And so they can have discriminatory outcomes. A downstream implication of this is a lack of trust, that if social media companies are using these types of models on their users, then they're going to lose the trust of their user base if they're discriminating against certain classes of users. This may, in some cases, lead to treating victims of hate speech as perpetrators if we're mistakenly classifying counter speech. And another problem here is that we may be missing the true positives. If we're picking up lots and lots of false positives, and potentially if social media platforms are using these techniques, then the human content moderators are going to be focusing a lot of their attention on these false positives and missing the true instances of online hate speech. So at the end of our paper, we do a little bit of speculation about some of the causes of this bias. And there are three main reasons I think we see these types of bias. The first is that we use dictionaries for sampling in many of these papers. And whatever words are in the dictionary inform the sample that we often get downstream. So for example, if you have the N word with the A at the end, that's a word that's generally used in an innocuous way by African Americans, and it's used very, very frequently online. So we end up oversampling that type of language due to the frequency with which certain words in our dictionary are used. And so the use of dictionaries for sampling kind of leads to the second problem of oversampling and potentially a lack of representativeness. And then the final issue is potentially social biases in language. So when we have our annotators, how are they evaluating these tweets when they label them? And how is their own kind of internal biases and prejudices becoming absorbed into our models? So this is something we know from, for example, studies of word embedding models, that they contain human-like biases. This is something I saw your syllabus, that you also, some of you have been reading this paper on by Joy Balamwini and Timnit Gebru about facial recognition systems and how they learn these biases. And so sampling is a big issue. I think if we're disproportionately over or undersampling certain groups, we're going to be producing biases in our models. And this is something that computer scientists have paid comparatively a little attention to. A lot of attention is about how can we improve our models and not how can we deal with potential biases and improve our training data. Another place that this bias may happen is the annotation process. And so in the Sapp et al. Paper, they do an interesting experiment, and they show that if you actually prime your annotators to be aware of issues of dialect and issues of racial bias, that they tend to classify fewer tweets as being offensive. So one final thing I would say about solutions is don't settle for post hoc solutions. I think this is another tendency in the computer science literature, is to think of, well, can we develop some type of machine learning approach to try to fix this bias after the fact and work with biased data? And so I really like the title of this paper, that they look at debiasing methods for word embeddings, and they compare it to this idea of putting lipstick on a pig, and that you're just kind of covering up the bias rather than removing it. So finally, I just wanted to spend a minute or so talking about some current challenges. One of the other big areas of bias in this literature is that there's been a huge focus on hate speech in the English language and comparatively little attention to other languages. And this led to, for example, in the case of Facebook, they had no one who spoke Burmese, and so were really unaware of this issue of like rampant hate speech in Myanmar, which was used in genocidal actions against the Rohingya Muslim minority. There are also issues. Today, I've just talked about racial bias, but there are potential intersectional biases and other types of groups that may be biased against by these types of approaches. This is one paper by Jay Kim and colleagues where they use a very similar, this is actually building on our paper, and they look at intersectional biases in one of these data sets and find that we do see that these biases are also related to gender as well as race. And then, you know, most of my work so far is focused on text, but lots of the content online that's potentially hateful content is multimodal content. That's a combination of images, text, and perhaps even video. And so this paper was by some researchers at Facebook, where they looked at how you might have a picture which on its own is not offensive, and some content that's also innocuous, and when you put them together, they create something offensive. These are some silly examples they used in their slides, but they do have a data set that shows some like real world examples of these that actually are extremely hateful. And they had a challenge where researchers were trying to develop a classifier to kind of identify this type of content. And I think this is a really interesting frontier in this research. And finally, another challenge here is the fact that social media companies have continually evolving policies, and the landscape of kind of what's considered to be acceptable is constantly changing, and it's very different across platforms. And so this often makes it quite hard to develop generalizable approaches when so much of what we consider to be hate speech can be very context specific. So if you're interested in following up about these papers, I'll share the slides with you, and you can find any references on this link. And that's all for my slideshow. So I will stop sharing my screen.
Thanks very much, Tom. That was just wonderful. I'll stop recording and maybe we can take some questions.